Okay guys, in this lecture we will be going through PLC programming. So PLC is Programmable Logic Controller. So I'll just give a quick overview of the previous lab. We went through what a PLC is, the need for PLCs, and we went through a simple car washing example, and we went through the wiring of PLC. So this is what a PLC looks like. It has inputs, outputs, uh, power, so 24 volts, typical for most PLCs, a programming cable. We went through a brief overview of the programming and logic, how it works. We went through the wiring diagram, and I also gave a simple PLC actual practical problem. So in this case there was a motor, and we want to turn it on using either a manual button or by using a combination of a pressure sensor and temperature sensor. So we looked at some basic PLC programming, and today we will actually be doing some actual programming. So you will be writing a program for some simple PLC task. So I also provided a link to a software. You have to install this software. If you had any issues with this, just let me know, but it should be quite simple. So then we went through the software, and I showed a basic simulator and how it works, but we did not actually do any programming. So the purpose of today's lab is to do some actual programming, and I have given a simple task over here in which we will design a PLC program that switches on a bulb when a switch is connected, and when the switch is disconnected the bulb should turn off. So basically on off switch for some output. So this is what we will be doing. So we have one input over here, which is the switch, and one output, which is the bulb. So we have one input and one output, and let's take a look at the wiring diagram. So obviously you can't actually make the connections because we don't have a physical PLC, but you can see it's quite simple. We have one switch which is connected to some input here, and a lamp which is connected to some input. Now in reality this is quite simplified. There would be some ground on the PLC. So if your switch has two pins, this would be the positive, this would be the negative, and the same for your lamp. So this is the positive and this would be the negative. So common ground for inputs and outputs. And I think I have mentioned that over here. So a ground pin would be connected. So let's actually start with the software. So your software should be installed as Do More Designer. So click this and click the designer. So no simulator, no loader or logger, it's the simple designer. So click this, and this should open up this screen for you. So you can close this. If this is the first time you're using this software, I don't think you'll get this menu. This just shows you your recent files. So I'll close this, and we need to start a new project. So I'll go on projects over here and I'll click new, and I will choose simulator because we don't have a physical PLC. If we had a PLC, then we could choose the different types, and they tell us, for example, the specifications. So this PLC has 10 inputs and outputs, and this is the frequency, and this is the power supply, and so on and so forth. But we just have a simple simulator, so I'll click this one and I'll give a name MSD PLC Lab Basics. So I'll click OK, and now a window will open in which I can actually do some ladder logic programming. The first thing we need to do is connect the simulator to this PLC. So first I'll go on PLC, connect, and you can see my sim, which is a simulator, is shown over here. So I'll click connect, and you should get this screen. So you click go online and view the disk project. So that's this one over here. Continue online, and this is not necessary, so we'll click next and finish. So if you did that, this PLC simulator should show up, and I can run this by clicking run, and I can stop this by dragging this slider to stop. So let's actually do some basic PLC programming. The simple most example is the bulb example, which I showed over here, and that one is over here. So if we look at this diagram, we simply have one input and one output. So the PLC diagram for that would look like this. So excuse my bad drawing, but we have one input, so this would be the switch, and then I'll connect this to an output, which is the bulb. It's as simple as this, nothing else. So we actually have to design this on the software. So I'll click my software, and you can see on the right side is an instruction box, and this is where I have many different things. I have timers, I have data manipulation, and so on and so forth. We will only look at the topmost one for now, which is contact. So this is a normally open contact. So I drag it here, so you can drag this over here, and it asks you for some number, and this is the address. If you look at this, this is an input, so I can, for my inputs, I will use x0 to x15 because this is all we have. So I'll write x0 and I'll press enter, or you can click this tick sign. So I'll just press enter, and now we have a contact. So remember, what will happen is when the switch is turned on, this contact will close and power will flow through this point, and my bulb will turn on. So let's say that is 1. And if my switch is off, the contact is open, power will flow through this point, but because this is closed, the circuit will end over here, or the ladder logic will end over here. So I've taken that over here, and if you put your mouse over this, you can get some information at the top. So this normally open contact is basically a simple relay. So this is my input. Now I need an output. So you can see that already one is present, but this says NOP, which stands for no instruction or no operation over here. So there are two ways to actually connect an output. You can double click this, which is the simplest way, and this says out and asks you for an address. So in this particular example, my digital, or this particular simulator, my outputs are Y0 to Y15. So I have 16 possible outputs. I'll just use Y0. So I'll write Y0 over here, and I'll press enter. So notice that it asks me that I can use Y0 to Y2047. But this depends on your PLC. So in my PLC, I only have 16 possible outputs. Therefore, I can only use Y0 up to Y15. But I'll use Y0, I'll press enter, and now my program is complete. So the next step to do is to write the code. So right now I've written a software, but this code is not uploaded to my PLC. So for that, I'll go here. Well, first I'll accept. So accept is a good way to check if there's any error in your code. I'll click accept. Nothing happened, so that means my code is fine. Now I'll write my PLC. Any notes? So I don't have anything. I'll just press OK. So I'll just ignore this and press no. And now I'll open my designer. The first step you have to do is always turn on your PLC. So I'll click run. So what should happen is if I press X0, Y0 turns on. So this is a simulation of the switch and bulb example. If I press my switch, then output is on. If I disconnect the switch, the lamp or bulb is off. So you can visualize this in the simulator. You can also visualize this in the program if you click status. So if I click this over here and I press X0, you can see that the background turns blue, and this means that the connection or power flow is going through. So when I click this again, there's no connection, which means there's no power. So obviously we will be referring to this, but you can also debug your code by just looking at the status over here. So this is how we make a simple PLC program, and I have explained all of that stepwise over here. So how to make a new project, how to select things, and this is our bulb example over here. So again, if you're confused by the video, you can simply follow this PowerPoint, and this will tell you everything you need to know. So let's make a practical example. We want to make an AND gate. An AND gate is quite simple. We have two inputs and one output, and the output is only true if both of my inputs are connected, or the contacts are made. So that is 1 and 1, so the output is 1. So in this particular case, let A be x0 and let B equals x1. So the logic should be that y0 should only be on when both of these buttons are on. If any one is off, then y0 should be deactivated or closed. So that is quite simple. All I have to do is take another input, I'll drag it over here, and I can use x1 for my second input, and now you can see I have an AND gate. If this contact is closed and this contact is closed, only then will my y0 turn on. So I'll accept the changes, and again I have to upload the code again, otherwise there will be no effect over here. So I'll turn off my PLC, I'll put it in stop, and you can see that nothing is happening because there's no power flow. I'll write to my PLC, and just a reminder that in PLC language, people usually say download to upload the code and upload to download. So it's the opposite. Download means that I'm uploading the code to my PLC. So I'll click OK. Everything is good. I'll run my PLC. I'll also run my status over here so that I can simulate this, and now you should see both at the same time. So x0 is on, which means power is going through this point, but x1 is off. And then when I press x1, you can see that x1 power is going through x1 through y0, and my y0 is on. So this is an example of an AND gate. Very simple, but very useful. And then again, if let's say x0 is off, power can go through this point, but because there's no connection over here, this connection is broken, and so y0 will be off. So I'll close this, I'll turn off my PLC, and then to delete this I can simply click a point and press delete. I'll click x0, and you can also press cut. Now if you want to delete the whole network, so let's say I have made a network over here, also called a rung, remember that. I can simply click this, right click and delete rung, and that would basically delete everything in the network or the rung. And if you want to close this instruction box, you can simply press edit mode again, so it disappears. I'll click it, and now you can see it again. And if by mistake you delete this, again you can double click this, and there is y0. Now let's say we want to make an OR gate. The difference between an OR gate is that let me just delete this. So in an OR gate you have something like this. Let's say this is x0 and this is y0 and this is your network. So in an OR gate, so if I just show you that, you can see that if any one input is 1, the output is true. So we need to make something like this. So for that, what you can do in a PLC programming is something called branching. So in branching you can take another leg over here. I'll collect another input and reconnect it at this point, and then this will be x1. So what can happen is my signal will come through this point, and it will first look from the top and see if x0 is open, it will go through this path. If not, we'll go here and we'll check this point. Is this x1 open or closed? If it's closed, then it will go through this point. And if this is closed, it goes through both points, but that does not make a difference because y0 will turn on. So we need to make something like this, which means that we have to make this branching part of the network. So how do we do that? It's quite simple. I'll go back to my designer. I'll just drag one contact, so I'll call this x0. Then I'll go at this particular point, I'll go in my edit menu, and you can see wire over here. So first I need to go down, then I need to go right, and then back up. So I'll click this, I'll go edit wire, so down, right, and then up. Now if this is inconvenient for you, you can simply remember the shortcut keys. It's quite simple. You can press Control and the arrow keys on your keyboard, so that's much easier. Now I can simply drag another input at this point, and I will call this x1. So I'll accept the changes, nothing happens, so no errors. I'll write to my PLC making sure this is off. I'll click OK, no errors. I'll click this and I will run this. So now you can see over here x0 is on, so power goes through this network or this point over here, and y0 is on. If I close this switch and I turn on x1, power goes through this point and y0 remains on, and then both will remain on. If both are on, then y0 will remain on. If both are off, then y0 will remain off, and you can also see that over here. So that is how you make a simple OR gate. Now again, I've explained the same thing over here. So if you have any issues, then you can tell me on Google Classrooms or WhatsApp or on Skype during an online lecture. So that was it for this simple lecture. You can do many things by just knowing basic logic. So if you have let's say you have a bulb over here and you have two different switches, let's say across your house. So if you wire x0 and x1 like this to a PLC, then you can simply write this programming ladder logic to complete that task. So you have a task over here, and that task is you have to make all of these gates. So 2 I've already done for you, and an OR. The remaining 4 you'll have to make. It's quite simple. First make a truth table, and then design this logic using the PLC, and then simply make a report. And in that report you can add the pictures. You don't have to send me the actual file. So one thing you can do is file, save the project, and you can write something over here. I'm not expecting you to do that. You can simply take screenshots, but you have to be very clear and show that it's your own work and not copied.